This is the presentation about topographic maps, also called contour maps. For this learning target, you're going to learn how to interpret topographic maps. You need to know how to read a topographic map accurately, locate areas of gentle and steep slope. You will also learn how to calculate gradient, plot correct profiles, and determine the direction of a stream. A contour map represents an elevated area, like a mountain, on a flat map. So these lines that you see that look like circles on my diagram, they represent different levels of elevation, or how high up above sea level you are. An important thing to remember is the smallest circle, the one on the inside of all the rest of them, has the highest elevation. That is the top of the mountain. Contour maps show the elevation of the land. So you'll see a map like this on the left with all these squiggly lines. It's actually showing you an area like this, drawing the mountain range. So you can see, like, here's the top of a mountain. On our topographic map, it looks like this small circle that's in the middle of all the other contour lines. You also see there's a river over here in the drawing. I can tell that there's a river over here just by looking at the shape of the contour lines. I'll explain how you do that later. A contour map looks like circular lines, but you can imagine from those circles what the mountain actually looks like from the side. The side view is called a profile. So we can actually make a graph that would show us what the side view of the mountain will look like, and we'll call that the profile. When you want to know how tall a mountain is on a map, you have to find the maximum possible elevation. In this case, the highest possible elevation is going to be right below what the next contour line might be on the map. So there's a flag showing you an elevation of 89 feet. The next contour line would probably be 90, but since the mountain is not 90 feet tall, the maximum possible elevation is 89 feet. So you see this line is 50, this line is 60, 70, 80, so the maximum elevation is 89. The next contour line that might have been 90 is not there, so the mountain cannot be 90 feet tall. Contour interval is the elevation difference between contour lines. So what is the contour interval on this map? If the lowest value is 50, and the next contour line says 75, and the next one 100, and the next one 125, what was the difference between each contour line? You should have found that it was 25 feet. Gradient is a formula. Gradient, this formula, is on the front cover of your reference table. Gradient equals the change in elevation divided by the actual distance. On your reference table, it says change in field value, because sometimes the lines on these maps might be for other variables rather than elevation. It could be about temperature or air pressure. You can always find gradient by finding the change between the value of two of those lines on the map and the distance between them. The steeper a slope is on a topographic map, the higher the number is going to be for gradient. So this topographic map, where you see the red line we see all these contour lines really close together, and that's showing me, this is the photograph of the same area, an incredibly steep slope. So again, the rule about that is the steeper the slope, the higher the gradient will be, and the closer the contour lines will be together. You see these lines are really close together, but over here there's more space between each of the contour lines. It's gradual on this side and steep on this side. This is what it looks like from the side. Gradual is like almost flat. Steep is like it's losing elevation very quickly. To calculate gradient, we'll do an example here. If the top of your mountain is 2,000 meters in elevation, and the bottom of your mountain is 500 meters in elevation, what is the gradient between these 2 points? First, you must find the difference in the elevation. So 2,000 minus 500 will tell you the difference between the elevation. 2,000 minus 500 is 1,500. Now you must divide that by the distance between those 2 points. To find distance, we use a scale. At the bottom of your map, you'll see a line with a number on it. In this case, the scale is the same size as the distance between my 2 points. It won't always be that way, but you can use like a piece of paper, measure it, and then put it down on the scale and see how it fits. So in this case, the distance is 5 kilometers. Remember, the difference between elevation was 1,500, and now we're dividing that by 5 kilometers. What is the gradient? If you did it correctly, you found 300 meters per kilometer. You also need to know how to tell the direction of a river's flow by looking at contour lines. So on a map like this, you have these circular contour lines. Remember, the top of the mountain is the smallest one in the middle. But sometimes you'll see this indentation on the contour line. We call that the V shape. It looks like an upside down V on this map. The V shape shows you the direction of the river, because the river always flows from high elevation, or the top of the mountain, to low elevation, bottom of the mountain. Water can't flow up a mountain. It always flows downhill. So the river flows out of the V shape, or opposite the pointy part of the V shape on the map. Which way is the river flowing? In which compass direction on this map? The answer is south. 10 things you should know about contour maps. If this is your map, we're going to have some questions about this map. You notice we're at point A over here, point B, point C, and point D. You also have point X and Y. Here's Red River, and this here is the ocean. You also have a scale in here. It's a little hard to see the distances, but I believe we have about, I'm not sure what the distances are. I'll have to tell you in class. Here are your questions. And here's your map.